Pulling force applied on a body obliquely with a horizontal rough surface. We have to find the expression of pulling force applied obliquely. Pulling force applied obliquely to a body to move it on a horizontal rough surface. Pulling force applied obliquely to a body to move it on a horizontal rough surface. In the diagram, this is a block of mass M which is placed on a horizontal rough surface. This is the horizontal rough surface on which a block or a body of mass M is placed. The weight of the body, that is mg, is acting vertically downwards. Mg is the weight of the block which is placed on the horizontal rough surface, and we can denote the normal reaction R. We can denote normal reaction R on the block applied by the horizontal rough surface, and we can denote the direction. This is the direction along which the pulling force, the external pulling force Fex, is acted on the body at an angle theta, with the horizontal direction. Fex be the pulling force which is applied on the body at an angle theta with the horizontal direction. The rectangular component of pulling force Fex in horizontal direction is Fex cos theta. Similarly, the other rectangular component which is acting in vertically upward direction is Fex sin theta. Let Fex be the pulling force. Let Fex be the pulling force applied on a body of mass M which is placed on a horizontal rough surface, or horizontal surface obliquely at an angle theta, with the horizontal. Fex be the pulling force applied on a body of mass M placed on a horizontal rough surface. The applied pulling force Fex is resolved into two rectangular components. Fex cos theta and Fex sin theta. Now the body will be at the verge of moving over the horizontal rough surface. The body will be at the verge of moving towards right along the rough horizontal surface, provided along the rough horizontal surface under the action of rectangular components, Fex cos theta of the pulling force applied to the body obliquely. So here the body will be at the verge of moving towards right along the horizontal rough surface under the action of rectangular component Fex cos theta and the limiting friction Fl. Will come into play. The limiting friction Fl will come into play on the surface in contact, in the opposite direction, Hence, what we can say, that is Fex cos theta is equal to limiting friction Fl, or Fex cos theta is equal to mu into R, where mu is the coefficient of static friction of the surface. Of the body with respect to the surface, comparing the equilibrium in vertical condition or in vertical direction. The rectangular component of applied force acting vertically upwards is equal to net force experienced by the body acting vertically upwards. A net force experienced by the body acting vertically downwards. Therefore, Fex sin theta will be equal to mg minus r. Fex sin theta will be equal to In this case, external force Fx sin theta will be equal to mg minus r, not r minus mg, it should be mg minus r. Fx sin theta will be equal to mg minus r, or comma r equal mg minus Fx sin theta. R is equal to mg minus Fx sin theta, which is equation 2. R is equal to mg minus Fx sin theta, which is the normal reaction on the body applied by the rough horizontal surface. Putting the expression of normal reaction R from equation 2 in equation 1. From equation 2 in equation 1 we get Fx cos theta will be equal to mu into R, and now putting the expression of R we get mu under bracket mg minus Fx sin theta, mg minus Fx sin theta, or comma Fx cos theta plus mu Fx sin theta is equal to mu mg. Now Fx is taken common, Fx under bracket cos theta plus mu sin theta is equal to mu mg. Therefore Fx is equal to mu mg divided by cos theta plus mu sin theta. Fx is equal to mu mg divided by cos theta plus mu sin theta, and that is the pulling force applied on the body. Pulling force applied on the body obliquely with respect to the horizontal direction. Fx is equal to mu mg divided by cos theta plus mu sin theta, which is the pulling force applied obliquely to a body, at an angle theta with the horizontal rough surface, to move it horizontally towards right. Fx is equal mu mg divided by cos theta plus mu sin theta, that is equation 3. Now the coefficient of static friction of the body with respect to the horizontal rough surface is mu, which is tan theta L, where theta L is the angle of friction of the body. Mu is equal to tan theta L, where theta L is the angle of friction of the body and the surface, which is equation 4. Using the equation 4 in equation 3 we get Fx is equal to mu mg divided by cos theta plus mu sin theta. Now putting the expression of mu, we get tan theta L mg divided by cos theta plus tan theta L into sin theta is equal to sin theta L by cos theta L into mg divided by cos theta plus sin theta L by cos theta L into sin theta, or comma sin theta L mg is equal to cos theta into cos theta L plus sin theta L into sin theta, or sin theta into sin theta L. Therefore Fex, that is the pulling force applied obliquely to the body, will have the expression. That means Fx is a pulling force applied obliquely to a body or on a body at an angle theta with the horizontal direction to move it over the rough horizontal surface towards right. And what should be the expression of Fx? That will be sin theta L mg divided by cos theta minus theta L. Sin theta L mg divided by, the denominator becomes what? The denominator is cos under bracket theta minus theta L. In place of cos theta L plus sin theta L, we can write cos theta minus theta L. Now we can compare the expression of pushing force applied obliquely on a body placed on a rough horizontal surface with the pulling force applied obliquely on the same body. This is a block or a body which is placed on a rough horizontal surface, and a pushing force Fx is acted obliquely to the body at an angle theta with the rough horizontal surface. Similarly, on the right hand side we consider the same body of mass m, and a pulling force Fx is acted at the same angle theta with the horizontal direction. So, what should be the expression of pushing force and pulling force applied obliquely to the body? In this case, what should be the expression of normal reaction force on the body applied by the rough horizontal surface? And the expression of pushing force will be mu mg divided by cos theta minus mu sin theta. On the right hand side, the expression of pulling force Fx is equal to mu mg divided by cos theta plus mu sin theta. Next expression of pushing force Fx will be sin theta L mg divided by cos theta plus theta L. But on the right hand side, the expression of pulling force will be sin theta L mg divided by cos theta minus theta L. Here R is the normal reaction force acting vertically upward direction, and mg is the weight of the body. Mg is the weight of the body, and in vertically downward direction, the rectangular component of pushing force Fx sin theta is also acting. Here R is equal to Fx sin theta plus mg, but on the right hand side we can denote the weight mg which is acting vertically downwards. R is the normal reaction force and rectangular component of pulling force is Fx sin theta. Now the expression of normal reaction R will be equal to mg minus Fx sin theta, mg minus Fx sin theta. Fx is equal to sin theta L mg divided by cos theta plus theta L, that is the pushing force. On the right hand side, pulling force is sin theta L mg divided by cos theta minus theta L.